students, welcome back in your physics class with me, Shraddha Shukla. I know you all are enjoying at home, but please don't forget to follow the safety rules, okay? Students, today we are going to discuss the topic light. Before beginning the topic, I'm going to ask you a question. Have you ever wondered how are we able to see the objects around us? I know, your obvious answer will be with our eyes. But no, this answer is neither wholly correct nor wholly wrong. So what is the correct answer? Okay, let's take an example. When you enter in your rooms and you don't switch on the lights, are you able to see the objects? No. When you switch on the lights, now can you see the objects? Yes. It is because the light from the tube incident on the objects and then reflect on our eyes. Okay? So, the light, for example, I'm taking the sun here. Okay, the light coming from the sun incident on the object and then reflects back into our eyes. Okay, like this. And that is how we are able to see the objects around us. Okay, now students, the objects that have their own light or they give the light on their own are known as luminous objects. Okay, such as sun. Sun has its own light. Also the stars. Stars also have their own light. This tube light, it also has its own light. What about the moon? No. Moon is a non-luminous object. The objects that do not have their own light are known as non-luminous object. The moon reflects back the light incident on it from the sun. So moon is just a non-luminous object. Okay. So I'm going to write down the definition here. Luminous object. The objects which give the light on their own are luminous object. Now, the second definition, non-luminous object. I can write it here. Non-luminous objects. The objects which do not have their own light but they only reflect back the light rays incident on it are non-luminous objects. Okay. So this is the definition of luminous and non-luminous object. Now I'm going to discuss the next topic, and that is rectilinear propagation of light. Rectilinear propagation of light. Okay, students, this word rectilinear, this means straight line. and propagation means traveling. So rectilinear propagation of light means the light traveling in a straight line. Okay, so basically I am going to state here that the light travels in a straight line. Now, to verify this, you can perform an experiment. Take a lit candle and a straight tube. Now, try to view the candle through it, through the tube. Are you able to see the candle? Yes. Now, bend the tube slightly and again try to view the candle through it. Are you able to do that? No, it is because the light travels in a straight line. Okay. Now students, there are many examples of light traveling in a straight line. So for example, phases of the moon, lunar and solar eclipse, shadows and pinhole camera. Today we are going to discuss here the pinhole camera. Okay. The pinhole camera. Okay, students, there was an Arab physicist. His name was Ibn al-Haram or al-Hazan. He has invented the precursor of pinhole camera based on the rectilinear propagation of light. Okay, so a precursor Ibn al-Hadam or al-Hazan. Okay, now this was the first ever camera to be produced. Okay, so the first ever camera to be made. This was the first ever camera to be made. Okay, now this camera makes an inverted image of the object. I am going to tell you the inverted image is like this. This image is an inverted image of this tree. Okay, so a pinhole camera makes an inverted image of any object. So our another point is this camera makes an inverted image of any object. Now, our fourth point that is to be remembered is that every camera has a lens. Even this camera also has a lens. But in a pinhole camera, the lens is replaced by a small hole. Okay? So, in a pinhole camera, the lens is replaced by a small hole or openings. Okay, so these are the four important points for pinhole camera. Now let's discuss about its principle. Students, the pinhole camera works on the principle that if the light is allowed to pass through a small hole, the image is formed on the screen. Okay? So I'm going to write the principle. Principle. If the light is allowed to pass through a small hole or openings, an image of the object is formed on the screen. Okay? And please remember, the image will always be inverted in a pinhole camera. Okay? Also, the image is always real, not virtual image. Okay? Now, the construction. The pinhole camera consists of a rectangular box. Okay? A box like this. A pinhole camera has a rectangular box like this. Okay? So, first important thing is a rectangular box and it should be blackened from the inside. Okay? Why is it so? So that there is no light for a perfect formation of image. Okay? So, a rectangular box which is or that is blackened from the inside. Okay? Now, second thing, it has one semi-transparent or you can say translucent screen on it. Okay? This image, this screen here is semi-transparent or you can say translucent. I'm sorry, I don't have so much space here. Students, transparent objects are which allow the light to pass through them, such as this cellophane. It is a transparent object, although it's a little dirty, but it is transparent. Now, translucent or semi-transparent means which allow only some amount of light to pass through it. Okay, such as this. See? You cannot see the object through them perfectly. I cannot see the camera perfectly through this object. Okay, so it is a semi-transparent or translucent object. And what are the opaque objects? Which do not allow any amount of light to pass through them, such as this duster. It will not allow, you cannot see through it. Okay, I cannot see through it. So this is an opaque object. So this face of the rectangular box is semi-transparent, and the face in front of this screen has a hole in it. Okay, so one face of this rectangular box is semi-transparent, and the face exactly in front of this screen has a hole. Okay, so one side or I can write 1. So one side of the box is semi transparent and the face exactly in front of it has a small hole in it. Okay, now I'll show you how the image is formed in it. That means the working. Students, first, it is based on the principle that light travels in a straight line. Now, what is the working? Place any object whose image you want to form in front of the opening or the hole. I'm going to draw just a rough sketch here. I'm so sorry. I'm not so good at drawings. Okay, suppose I'm taking this tree. Okay, it should be in front of this hole. Now, the light entering through this hole will make an image here. But please remember the image is always inverted. Okay? Like this. Although it's not perfect, but please try to imagine. So I'm going to write down that the object is placed in front of the pinhole camera and the light coming, or you can say reflected back, reflected from the object is allowed to pass through the hole. Then the image, or please remember inverted image. Let me write down the inverted image of the object is formed on the screen. Okay? Okay? Now, please, now there are few important points. If you decrease the distance between this object and the opening, if you decrease this distance, the size of the image will increase. Okay? If you are increasing this distance, if you are decreasing this distance, the size of the image increases. Okay? And inversely, if you increase this distance, the distance between the object and the hole, if you are increasing this distance, the size of the image will decrease. Okay? So I'm going to write down a few points here. Number 1, if the distance between the object and the hole decreases, the size of the image increases, and inversely if the distance between the object and the hole increases, the size of the hole of the image decreases. Okay? Another point. The size of the image depends upon the distance between the hole and the screen. If this distance is increasing, the size of the image is increasing. If this distance is decreasing, the size of the object is decreasing. Okay, so size of the image is directly proportional to the distance between the hole and the screen. Distance between the hole and the screen. Okay, now next point. As long as this hole in the pinhole camera is small, it will not affect the size of the image. Okay, so third point is as long as the hole is very small, it will not affect the image of the object. Okay? Now students, whether you change the distance between the hole and the object, the distance between the hole and the screen, all of them will not affect the sharpness of this image. It will still be focused and sharp. Okay, so the image will be sharp and focused, so there is no need of any focusing. Okay, and the fifth point is, since the image can be formed on the screen, it is not imaginary, hence the image is real. Okay, inverted but real. So the image formed by the pinhole camera is real and inverted. Okay, so this was all about the pinhole camera. In the next class, we are going to discuss about the shadows and eclipses. Okay, till then, stay home, stay safe. Thank you.